Channel. This is T. Kirtana from Sri Venkateswara College of Engineering, Department of Electronics and Communication. So today's topic is explore the world of normal distribution. Normal distribution is a fundamental concept in statistics. It is a foundation upon which many statistical tools are built. Let us dive deeper and explore it. So who invented normal distribution? The two people are invented the normal distribution, that is Pierre-Simon Laplace, and Laplace is credited with developing the first version of the normal distribution in the earlier 19th century while studying the errors in astronomical measurements. Then Carl Friedrich Gauss, he is also one of the scientists who has invented the normal distribution. So the Gauss, who independently discovered the distribution in 1809 while studying the measurements, who is most often associated invention. Then properties of normal distribution. So what are the properties of normal distribution? Bell shape and normal distribution are known for their distinctive bell shape. The curve is symmetrical and centered around its mean, with the highest point occurring at the mean. Mean and standard deviation. The mean and standard deviation completely describe a normal curve. The mean determines the center of the curve and the standard deviation determines the width. And the empirical rule. Empirical rule. 68% of the data falls within the standard deviation of the mean. 95% falls within 2 standard deviation and 99.7% falls within 3 standard deviations. Asymptotic. Asymptotic normal distribution extend to infinity, never touching the x-axis but getting arbitrarily close to it. Then we have the standard normal distributions uh, and the symbols are shown here. Then the standard normal distribution is a special case of the normal distribution with mean 0 and standard deviation 1. So the distribution is important because it allows us to compare the different normal distributions and perform some calculations more essentially. The following sessions will explore the concept of z-scores and how they relate to the second standard normal distribution. Zeros, z-scores and probability calculation. So we are going to learn about z-scores and probability calculation. So first one, what are z-scores? The z-score is the number of standard deviations that a data point is from the mean of its distribution. It can be positive or negative depending on whether the data point is above or below the mean. So next one is calculate z-scores. So this is what z is equals to x minus mu divided by sigma, where mu is the mean of the distribution and sigma is the standard deviation of the distribution and x is the data point in the equation. Use z-scores to find the probabilities. So by using standardized tables, we can normalize the probabilities for z-scores. The table proportion of observation that falls below the z-scores as well as area between them. The next is using tables to find probabilities. Using the Z table, we can find the probability that a random variable from the standard normal distribution will be between two values or less than or greater than a certain value. So Z table, a standard normal distribution table, also called Z table, is a mathematical table for the values of sigma, which are the values of the cumulative distribution function of the normal distribution. So this is the Z table we are going to see. Even the negative also we are going to see and positive also we are going to see here. Uh, so this is what we'll see from 0 to minus 2.40 and from 0 to 0 0.09, 0.0 to 0.09. Then Z table format. The rows of the table represent the ones digit or the first digit after the decimal of the z-scores, and the columns represent the second digit after the decimal of the z-scores. So this is the normal distribution are symmetric. So here we are going to see the plot of the graph where we are going to see 50% area one side and 50% area another side. Then normal distribution formulas. The probability density function f of x is equals to 1 by sigma root over 2 pi into e to the power of minus x minus mu whole square divided by 2 sigma square. So this is the probability density function, and the inverse normal distribution function is for a given area under the normal distribution curve, the inverse normal distribution function calculates corresponding values of x. Then next one is applications of normal distribution. So quality control. So here we'll see the quality control on the x-axis where the curve will form here. So the normal distribution are used in the quality control to identify and address the problems. Then stock market tradings. The normal distributions are used to understand the stock market trades and how to make investment decisions. Then medical testing. Normal distributions are used to interpret medical test results, evaluate the accuracy of diagnostic tests, and assesses the effectiveness of treatments. Then psychology. Normal distribution are used to understand the distribution of IQ scores in populations and to evaluate the efficiency of the treatments. Assumptions for using normal distribution. First one, independency. Observations in the sample must be independent of each other. Random sampling. The sampling must be selected randomly from the population. Then normality. Data must be normally distributed. Then equal variancy. Variancy in the population must be homoscedastically. Then limitations and alternatives. Limitations. Only valid for continuous data, assumes schematic distribution, sensitivity to outliers, may not work well with small sample sizes, requires the conceptions of normality, may not be suitable for non-linear relationships. Then alternatives are non-parametric statistics, bootstrapping, simulation-based methods, robust regression techniques, generalized linear models, machine learning algorithms. Then calculating the z-scores. How to calculate the z-scores? First one, find the mean and standard deviation. To calculate a z-scores, you first need to know the mean and standard deviation of the distribution from which the data came. So find the value of interest. You then need to determine which values or values you want to transform into a z-score. Then apply the formula, the mathematical formula of calculating z-scores. Z is equals to x minus mu divided by sigma, where x is the value of the mean of the distribution and sigma is the deviation of the distribution. Then real world examples of normal distribution. So human height is a real world normal distribution example. Height in a population follows a normal distribution with most people clustered around the mean and fewer people at the extremes. Then IQ scores. IQ scores follow a normal distribution. Most people have scores around the mean of 100 and fewer people have scores at the extremes. Then we have stock prices. The daily changes in the stock prices also tend to follow the distribution, normal distribution. Then conclusion. Normal distribution plays a crucial role in statistics and is a powerful tool in many fields. By understanding the properties and applications of normal distribution, you can make more informed decisions and draw a normal conclusions. Thank you.